So, how do we in the real world measure current and voltage? It's one thing to be able to do all the math, but after, let's just say we build the circuit, how do we measure that actually what we've built is actually working properly and giving us the voltage that we need and the current that we need? And so we have two tools to do that, a voltmeter and an ammeter. And interestingly, we actually, in lab right now, we have something called the multimeter, and the multimeter contains both of these functions and a couple more. But a strict voltmeter measures voltage without drawing any current. So what you would do with the voltmeter, you have two lines coming out of it, one for your input, one for essentially the first part that you're going to measure, and then one for the second part that you're going to measure. And by plugging the circuit, just tapping the circuit in on top of that, you're going to be able to measure what the voltage change is over that resistor. So in the top right image that we're looking at, the voltmeter is plugged in over that resistor, and that's going to show us the voltage drop of that resistor. So given the same amount of current in the system, we can be able to see what the voltage drop is, and actually, with some clever math, calculate what the resistance is, as long as we know two of the three, voltage or resistance or current. And we're going to get to that in a minute. Now, an ammeter, on the other hand, an ammeter has to be plugged into the circuit itself to work. An ammeter measures current without dropping any voltage. And there's a couple cool derivations that show this that we've had in physics, and if you ask, I can go through a couple of them as well to show you why this works. But essentially, just remember, when you're using an ammeter, it has to be within your circuit. You can't just tap it to 2 points in the circuit and have it take current readings. Essentially, then you're creating a current divider, and you're not going to get the right answer. So, if we look down at the bottom right picture, this shows, again, another way of measuring two different voltages. So you're measuring two different voltage differences. The first difference is over the first resistor. So what is the voltage drop of just that one resistor? And then the second one on the right is measuring the voltage drop of both resistors. And the voltage drop of both resistors should be equal to the voltage that you apply in the left hand, so whatever the battery is. So if you have a 9-volt battery or 9-volt power supply, the total VA, so that includes both resistors, should have a 9-volt drop to bring it down to 0, because that's where we've drawn our ground in the bottom. Now, the voltage of AB, so the voltage over that first resistor, is going to depend on the values of the two resistors. So that's something that we're going to get into when we're solving resistor circuits later. Question: What does this mean about the internal resistance of each meter? What is the internal resistance of a voltmeter, and what is the internal resistance of an ammeter? I'm going to ask that one in class.